Hi, and welcome to the first in a six-part series explaining how to quickly deploy a powerful, fast, and scalable data analytics solution using the free components of the Elastic Stack. In this video, I'll introduce the goals and audience of this series and give a brief overview of what the remaining videos will cover. My goal with this series is to introduce and demonstrate a general-purpose data analytics solution that I, after having researched and used a variety of alternatives over the years, have found to provide easily the highest return on investment in a wide variety of medium-scale situations. For the purposes of this series, I'll define a data analytics solution as the combination of usefully modeled data safely stored in a scalable database and made readily available to analysts in tools that are easy for them to use and share with their audience. In most cases, it should also be fast and enable ad hoc analysis. In other words, the analysts themselves should be empowered to come up with questions and find the answers on their own without waiting on pre-processing to be implemented and executed first. The best solution for any given situation will vary widely depending on the size and complexity of the data, analysis, and audience, which we'll refer to as its scale. On the smaller end of the scale spectrum, say thousands or millions of objects and just a few users, importing your data directly into tools like Power BI or Tableau can give you a lot of power in a reasonably affordable package. On the other hand, if you're dealing with huge interrelated datasets in a large IT department with a lot of data consumers, then you'll likely need to invest substantial resources into something more optimized for your needs. The approach I'll describe isn't necessarily inappropriate in all those situations. Some, such as IT infrastructure logging, happen to be its forte regardless of scale, but I find it to be particularly compelling at the medium scale, which I'll define as follows. A data quantity ranging from around 1 million to around 1 billion rows or objects, a budget in the single to double-digit thousands, a technical staff of 1 to 2 engineers who could be part-time, a data audience consisting of analysts or viewers in the tens to hundreds, analysis that should rarely require programming or custom database queries, and a data structure that is fairly consistent but could be evolving and may include multiple types of object, including nesting. Think JSON. I suspect this encompasses the fat center of the distribution curve when it comes to data analytics problems. This is the sort of scale most small businesses will be operating at, and there are probably dozens or even hundreds of such scenarios within larger companies. Now, to be clear, I'm not saying that the solution I'll describe will completely meet everyone's needs, even if they fall within this medium scale definition. There are certainly limitations, and in some cases you'll need to augment this with other tools and technologies that enable more complex or tailored analysis and workflows. But even then, I think you'll still find deploying the stack to be worthwhile. As I mentioned at the top, this series will be focused on using something called the Elastic Stack to deploy a data analytics solution. The Elastic Stack refers to a suite of both open source and commercially licensed products produced by the company Elastic, and in this video we'll be focusing on two, both of which are open source, Elasticsearch and Kibana. Elasticsearch is the core of the Elastic Stack and provides scalable data storage, indexing, and query execution. Kibana is a browser-based data discovery and visualization tool designed specifically for Elasticsearch and provides the user interface for both creating and sharing analysis. You may have heard Elasticsearch in the context of adding search to a website, or you may have heard of the ELK stack, which refers to Elasticsearch and Kibana plus another project called Logstash, which I mentioned earlier is a popular solution for storing and analyzing IT infrastructure logs. But I've found these technologies to have much more general-purpose applications as well. What I find so compelling about Elasticsearch and Kibana is that both products are very easy to manage all the way from a simple prototype to a production cluster, and because Kibana is built for Elasticsearch rather than trying to support multiple database technologies, together they form a fully integrated and mature solution. I found both products to also have a lot of smart details in their designs that makes them flexible and easy to scale up, such as how trivial it is to combine separate datasets, or indexes in Elasticsearch terms, into single views using wildcards, how easy it is to enable replication and sharding, and its ability to dynamically build a mapping or schema as the data is inserted. There's also an ecosystem of first and third-party add-ons, some free, that enable it to grow with your needs. If budget allows, they also have a managed cloud product as well, which for small deployments includes their paid features at no additional cost. Though technically a search engine, Elasticsearch is also a lot like a database, and in some cases may be the only place you need to store your data. However, for a more robust and production-grade architecture, Elasticsearch is usually combined with a true database, which serves as the primary source of truth. While any type of database can be used with Elasticsearch, I recommend MongoDB for new designs because both are JSON-based document stores, and it's natural to have a one-to-one mapping between a Mongo document and its corresponding Elasticsearch object. In this series, we'll be going through a simple example using climate data from the U.S. National Oceanic and Atmospheric Administration, or NOAA. We'll spin up MongoDB, Elasticsearch, and Kibana instances using Docker, review a simple ETL Python script I've written to ingest this data into MongoDB, and then see how easy it is to synchronize Mongo with Elasticsearch. We'll then spend some time learning Kibana, and finally discuss next steps including production deployments and optional add-ons. As far as prerequisite skills for this series, you should at least be comfortable with minimal programming in Python and basic command line interactions. When you're ready, play the next video and we'll get started.